All right, so this week we are moving on to Chapter 2, which is all about hardware. All right. Some of you, again, will be really good with this topic. Some of you probably don't even think about the computer that you're using. All right. You're just like, it's a computer, it works, it gets the job done. Maybe you're like, this computer's slower than other computers. That one's not too surprising for me. But for the most part, you guys probably don't think a whole lot about the computers that you're working on. Now, we did talk about this a little bit last week, the different operating systems. All right, so I've kind of got them all just strewn up there for you. Windows, as we said, was kind of the most used one. Laptops, tablets, desktops, all-in-ones, smartphones. There are some smartphones with Windows on them. All right, not very many. I can't even name one that's being manufactured today. So, not saying they aren't still being manufactured. I'm just saying I can't name them. All right, then we've got Apple, which is our Macintosh, laptops, desktops, all-in-ones. All right. Notice there's no tablets on there, all right? Because the Mac tablet, the iPad, runs on iOS, which is the next on the list. So tablets, iPhones, iPod Touches, yes. iPod Touches are still a thing. All right? I believe they're actually being faded away at this point. I don't know if they're actually making them anymore, but they are still a thing out there. Then we've got Android, which is smartphones and tablets. You technically could have like a computer running on Android if you really, really wanted it. Most people don't want it that way. I don't blame them. Then we've got our Linux, which is our open source stuff. And Linux and then Unix should be on that list too, but it's not. And then you've got your Chrome OS. As I said, Chromebooks are really where that's happening. I think there are some like tablety devices that are running Chrome OS, but I'm not positive on that one. So anyway, those are kind of your general use ones there. You've got, kind of 3 operating system, 2 tablety things, and then one that's just a laptop. But so, the parts, all right? Now, if you ever are bored and you have a desktop, I suggest taking the side off of it, just to look inside of it, all right? This is roughly what you'll see if you have a newish computer, all right? Newish, probably the last 10 plus years, you're gonna have something that looks somewhat similar to this. Obviously, this is gonna be a fancier case than probably many of you would have, but still, it's kind of there. You've got your your CPU, which is going to be under, I can draw on the screen. Maybe I can draw? No, not gonna let me. Okay, I can't draw. All right, anyway, the CPU is located under that fan right there. That is gonna be our cooling solution. Our motherboard is what the CPU and everything else attaches to. That's kind of like the backbone of a computer. Your RAM is your temporary memory. We're gonna go into more in depth in all of this, but just like to kind of quick hit it up. Your storage is going to be traditionally hard drives, but SSDs are kind of taking over. They're going to be on the right-hand side there. Our GPU is our graphics. That may or may not be built into the CPU. We've got a power supply, which in this case is at the very bottom. Some towers are at the very top. It really just depends on the manufacturer. I think bottom is kind of starting to take over, having the power supply at the very bottom of the case. But I could have you backwards there. We have some sort of cooling. As I said, we got a fan up there, and then we also going to have peripherals. But we'll come back to all this in a minute. So let's start off with the wonderful world of the CPU. Now, there are 2 major brands of CPU. Anyone know what they are? Intel and AMD. Those are the 2 biggest brands in, CPUs. They are kind of going, they're the 2 fighting. We got Team Blue, which is Intel, and Team Red, which is AMD. All right. People are very, very specific about I want Intel or I want AMD. There are many people who are like, oh, Team Intel all the way. All right. It's like Republicans and Democrats. Same idea with computer processors. And then there's people like me who I don't give a damn. All right. At the point of me building a computer, whichever one's the best bang for the buck is the one that I'm going to buy. All right. When I built my computer back in 2018, I think it was, I went an Intel 8700K, just what I went with. And nowadays, AMD is going to be the better bang for your buck. So it's a little bit of a give and take going on, unless you're a real big diehard. Then you're just going to go with whatever the best is from that company. But anyway, so we have tasks here, all right, which is how the computer is going to process. That's what's happening in the bottom corner of my screen up there. And there are 4 different tasks. Do I have this on a separate screen? Separate PowerPoint? No, I do not. Okay, so the 4 tasks are input, processing, output, and storage. This is also the instruction cycle. Didn't realize I had it on there twice. Input would also be kind of like fetching. So you're retrieving the instruction from your memory. Well, All right, we're a little different here on the instructions and the tasks, but kind of go together. So we got fetch. We'll go with that. Retrieves the instruction from memory. So this is when it's going to go, hey, I'm supposed to be doing something. I'm supposed to be opening a program, whatever it is. So it's going to the memory saying, hey, I need this information, and it gets the information it needs. Then we move into the decode. It takes the instructions that are written on the computer and translates that into something that the CPU can actually understand, the computer code. All right. So we go from maybe human readable code to binary or something along those lines. Then we actually execute it, and that we're going to use the ALU for. That would be the arithmetic logic unit. This is what performs arithmetic and logic calculations. And then after we're done executing, we store it, and we take those results and we write them back to memory. All right, basically the same idea as, actually, yeah, let's go on there. Fetch, decode, execute, store. All right. So that's the ALUs, the arithmetic logic unit, as I said. The control unit, that is, coordinates the movement of data through the CPU. All right. Now, when you are looking at your computer, there are two things that are very important for us. All right. The first one is how many cores does it have? Now, it used to be again, back when I was in high school, one core was all you got. Yeah, I know. Way back when I was in high school. I used to love saying that when I just finished grad school and been like, trust me, guys, I was there. Last year, I was taking classes. And I'm way past that point now, so it's a little longer ago. But anyway, yeah, back in 2007, I had a single 2.4 gigahertz processor. All right. That was it. All right. Nowadays, when I went to college, I said I got a quad core 2.4 gigahertz processor, which was pretty nice at the time. Nowadays, I've got in my 8700K, that was a 6-core, 3 point something, I think, gigahertz processor. I'm not quite sure on the speed. All right. And nowadays, it's you want the AMD whatever, that's got 16 or 32 cores. Holy crap, the number of cores just keeps skyrocketing as you go up the CPU lane from years ago. So the number of cores is going to matter. Now, that is not the end-all situation. Because some programs on your computer are only designed to handle one core at a time. They don't know how to use all those different cores. So if you ever load a program up, you're like, this is really slow, and you actually go look at Task Manager to see what your CPU is doing, you're like, why is only one core being used? Well, the program only knows how to use that one core. The program was not designed to be sending all these different commands to all the different processors. So that's kind of a big downside there. So on top of the cores the cores is the clock speed. All right. And this is going to have traditionally two numbers to it. You're going to have a base clock speed and then a boost clock speed. The base clock speed is what that will run at 24/7 traditionally across all your cores. So it's 3 gigahertz, 4 gigahertz. I think we're pushing 4 to 5 gigahertz now, maybe for some base clock speeds. Not the base, definitely the boost. So that's what it's going to run all the cores at, would be that base clock speed. Now, you also have that boost. And the boost will run some of those cores at a much higher level. That could be a single core up to 5 gigahertz on that 16-core processor, where the base might be 3. So it's well, that's a nice big jump, but it's only, one core. So it's not a lot of work that's being done. So you got to do a little bit of give and take going on here when it comes to those clock speeds. Many processors are overclockable. So yes, the manufacturer says this is rated for 3 and will boost to 5. Well, you're like, screw that. I've got stupid amounts of cooling on here because I'm cooling it with liquid nitrogen. Not many people are going to cool their computer with liquid nitrogen. But you could be like, I want my base to be 5 gigahertz. So everything is running at 5 gig. 100% plausible. It is doable. But it is not likely that's going to happen for the average person. All right. They might boost them, overclock it a little bit. Intel, if you're going to overclock, you need that K series. All right. So be aware of that. AMD, I want to say all of them are unlocked, but I'm not positive on that one. So the clock speed is going to be very important in that aspect. So we have, when I was talking about that, I said gigahertz. For those who don't know, giga is billion or times 10 to the 9th. So if it's saying it's a 4 gigahertz processor, that means it can process 4 billion instructions per second. A lot of instructions happening per second. All right. Now you can probably see why that clock speed is going to be so important, because the higher that clock speed, the more things it can do per second. My quad-core 2.4 gigahertz processor was then roughly a 10 gigahertz processor if you multiply it all together. So back in college, that'd be almost the equivalent of a 2-core processor today. So a little bit of give and take going on there. All right. Now, right between those up on the screen, I have flops. And that stands for floating point operations per second. All right. That is how we are measuring supercomputers. All right. At someday, we're going to measure traditional computers in flops. We're not there yet. In 50 years, the supercomputer today is going to be equivalent to the normal computer then, or something along those lines. We're not there. But flops is, as I said, used for supercomputers, and this is measured in petaflops, which is 10 to the 15th power. So that takes our gigahertz and just annihilates it. Add 6 more zeros to that one. That is a lot of processing, and they're measuring floating point operations. So just kind of something to think about. Now, up on the screen, I also have hyperthreading. Anyone know what hyperthreading is? Sounds really important, right? Hyper, really fast. All right. Hyperthreading is basically the process of splitting your CPU, each individual core, into 2 cores. All right. It is not actually doing it. That is physically impossible. But it makes the computer think it's 2 separate cores. And it's there for speed purposes, because if your computer is constantly working at a very specific speed and one core finishes its task early and it's waiting for the instruction for the next loop to go around, what it can do is it can go, oh, okay, let me go process this other pseudo core. So it takes your quad core and makes it an octa-core type of thing. Now, it is not a perfect solution. Traditionally, it does make your computer faster. Not always. There are certain instances where you might want to turn hyperthreading off, and normally that is an option in your BIOS. You can go click that box and it will disable hyperthreading on your CPU. So it is something that you want to think about. Not all computers can be hyperthreaded. If you ever go look online at CPU specs, it might go, 4 core, 8 threads. Traditionally is what it's going to say. But it might say 4 core, 4 threads, which means hyperthreading does not work on this device. So something to think about. So that's that. And then the last thing up there on the screen right now I have is pipelining. All right. Pipelining is improving the speed of a single processor. So think about this, right? You individually working, if I said, hey, go complete these tasks, first I'm going to tell you the task, then you're going to go complete the task, and then you're going to come back to me and say, I'm done, what should I do next? All right. What pipelining is it's kind of making you do 2 things at once. First, I'm going to tell you to do something. And then as you're doing it, I'm going to tell you what the next thing you should be doing is. So it's always basically processing 2 things at the same time, or maybe 4. So if we take those instruction cycles, and it always has the next, decode, execute, fetch, or store ready to be happening. So it's, in theory, like doubling the speed, because it's never just waiting around. It's always just like half a step ahead. All right. How many of you have worked with somebody who's a half a step ahead of you? You're building a house, and you're like, I need the circular saw, and there they are holding it for you. Like, here you go. And they could just kind of picture like what's going to happen next. You're like, okay, right now we're going to cut 2x4 the length. The next thing he's going to need hammer and nails to put that frame together. Then he's going to need an extra 2x4 as a brace to hold the wall up. All right, that would be pipelining. That's basically having your little helper there, making sure that as soon as you're ready to put that wall up, he's there with the tools and supplies for you to do that. All right, so it's allowing that computer to be just a little bit faster is what it comes down to. So yeah. The last thing I have on this, which I don't have up on the screen, is a GPU. As I did mention on the last slide, some CPUs have a built-in GPU. And basically all laptops, especially like Ultrabooks and things, there's no dedicated GPU in here. It's whatever's built into the CPU. That is what you're reliant on. Does it get the job done? Yes. Is it the best GPU in the world? No. All right. So it's just something that you want to think about. If you're going to have something that is highly GPU intensive, you don't want to rely on the one built into your CPU. Having said that, having that backup one, some laptops that do have dedicated GPUs will actually switch between them depending on what they're doing. So like if all you're doing is processing Word, it's going to shut down your dedicated GPU and run off the built-in one because it's more efficient. So you're not going to be using as much power. Your laptop's going to have better battery life. However, then when you open up gaming and you're trying to get 60 FPS in whatever game you're playing, it's going to be like, that built-in one, not going to handle it. We're going to rock the dedicated one. So it knows when to switch between them. So it's really kind of impressive to me that we've got computers that can do that. They can go to the super efficient way or the non-efficient way for power when we need it. So kind of a nice little benefit there. When it comes to cooling, all right, we got to do it. We have to move the heat away from the CPU. All right. As I mentioned to you guys, I was like, I'm just going to heat my basement with my gaming rig, mining Bitcoin this winter, because that was my system. If I was going to run baseboard heat, I might as well just let my computer output some heat. So we're going to have to cool things. Now, up on the screen, I've got another picture to show you in a minute. This is tower coolers. They're much easier to kind of visualize and see what's going on. In your laptop, you have some very custom cooling loops. All right, they're crazy. They're really thin normally. It's kind of amazing what they can do in a small CPU chassis with technology nowadays. But anyway, whole point of cooling is to move heat away from the components. All right, the two biggest generators of heat source in your computer are the CPU and your GPU if you have a dedicated GPU. Those are the two biggest. Now, on your motherboard, there are other components that do need cooling, like your VRMs, your power delivery. Not really, you shouldn't need an SSD. But anyway, your CPU and your GPU are the two main ones. And there are two main ways of dealing with heat at a very specific source. And that is with air cooling, which is what I have up here on the screen. At the very bottom of that picture, there's a little aluminum or copper block. That's actually what touches your CPU. You put a little bit of thermal paste on that CPU before you switch this down. And the thermal paste helps conduct heat away from that CPU. That CPU is not going to be perfectly flat. And your GPU probably is, or not GPU, your cooler probably isn't perfectly flat. So that's why we have that thermal paste. It's to help take up those irregularities and allow heat to transfer between the two more consistently. So put some thermal paste down, slap this cooler on top, screw it down so there's a specific amount of tension. Normally there are screws or springs that keep it having the right amount of tension, and that allows the heat to go through heat pipes up into the cooling fins. And then we take just air with the two. This one has two fans on it. There's one on the front. There's one in the middle. Some will have three, one on the back side as well. Some will just be this little like hockey puck that sits right on top of the CPU. It all depends on how much heat we have to remove. Intel is known for being hot, like just blasting out heat. AMD traditionally is cooler for the same amount of processing power, which is one of the reasons why AMD is killing it right now. So that is your traditional, I'm going to call it a tower cooler. All right. If we go to the next one, we've got a traditional AIO, or all-in-one water cooler. So here you can see we've got the block that is on the left. That will actually go again on the CPU. And then we've got tubing lines that go out to a radiator, and we have fans on. So there's actually water being pumped through this all-in-one. And then the fans blow air across the radiator, just like your car cools down, and that takes the heat out. All right. There's benefits and drawbacks to both. All right. You can have a custom water loop designed. All right. However, most people, unless you're really into it, don't want to go the custom water loop. There's actually a lot of maintenance that goes along with a custom water loop. All right. Not only maintenance, but also having to build it and make sure it's watertight, because you don't want water dripping on your PC. All right. So if you're going to go water cooling, I would suggest a AIO. I'd also suggest at least a 240 millimeter AIO, which would be two fans wide. They do make 120s. They do make 360s. I don't know if they make 480s, but they do make bigger ones. I would probably suggest going this route. And if you're going all in one, that's probably because you want to go do some overclocking, and your stock heatsink can't handle it. Now, the wonderful world of Linus Tech Tips, for those who haven't heard of him, he's a YouTuber. For those of you who hate him, I'm sorry, but I'm going to talk about him. He did a comparison of water coolers versus air tower coolers, and they did find that the air tower coolers, for the most part, a good one, can keep up with an all-in-one water cooler. So like, okay, so what's the benefit of this? Well, might be it run a little bit quieter, so you don't hear the fan spinning as much. It might takes longer to get heat soaked because we have all this water mass to heat up instead of just cooling fins. So it might boost a little bit longer before it slows your processor down, whatever the case. So there are some benefits to water cooling, but for the most part, a good tower cooler is all you really need. So just kind of something to think about. And then last on here, I have case fans. And here is a lovely little picture for you. Traditionally, the larger the fan you can go, the quieter your computer is going to be. All right. Larger fans can spin slower and move the same amount of air. So you do want to kind of go to the largest fan that you can. Most computers are going to be able to handle 120s. Most desktops, I should handle that. Some of them can do 140s, and the very rare few can do the 200. I would stay away from the 80. They're going to be spinning a lot faster. The reason that we can hear the switches up there, just loud as all hell, is because they only have like a 40mm fan in them. And to move enough air to keep everything cool, they have to spin at very high speeds. So that is the downside to the smaller fans. They're whiny and whatnot. You ever go into like an actual server room, it's going to sound like an airplane taking off because there are so many of those little fans just spinning at such high speeds to get enough air through all the servers and networking equipment and whatnot. It's just loud. So anyway, those are some different sizes fans. The other thing when you're building a custom computer, again, if you have just buying a desktop, you're not really going to worry about this. But with the fans in the computer, you have three options. You can have a positive pressure system, a negative pressure system, or a balanced pressure system. And what that means is how much air are you forcing in versus how much are you forcing out. So if you only have one fan in your tower and you're sucking air into the computer, you're creating positive pressure. Because you're sucking the air in, you're letting it find its own way out through whatever holes there are. But in theory, the pressure inside your case is going to be slightly higher. All right. If you have only one fan and you did it the opposite, where you're pulling air out of the case, that's going to be negative. So it's actually creating a slight vacuum that the air all has to come find. Third option would be that balance where you have one fan in, one fan out, and it's in theory keeping the pressure inside the same as the outside the case. The other thing you want to think about when it comes to your computer is filtering. Now, I'm not saying you should put a HEPA filter on top of your computer case. That'd be pretty funny to see. But you may want to have some sort of air filter on that case, especially if you have animals and your computer is on the floor. Because the more crap that gets blown into your case, all the hair and whatnot, the more likely your computer is to have problems. From A, overheating, and B, from like short circuits and things getting weird because of all that buildup of dirt and grime on tracks and traces and pins and things like that. So ideally, you want to filter your air input, and on your air out, you don't need to filter it. Canned air is a good option for cleaning out your case every once in a while, which again I would highly suggest do, whether it's pre-built or you built it yourself. You should blow out your case. Officially, you really want to use that canned air because I think it's like perfectly dry and inert. There's no crap in it, those types of things. Oh yeah, well I can't say I've experienced that one. However, personally, I just use my air compressor. I've got a wood shop, I got an air compressor. That's going to have moisture in it. There might be some oils in it, so it's not really great for your computer. I'm like, you know what? I'm not going to go buy a can of compressed air. I'm just going to use the air compressor that I have. So that's my system. Really probably not the best. All right. Maybe just like your shop vac or something with it on blow might be a better option for you. I don't know. I like my compressed air option. So that is what I use. Fun side note on that compressed air, if you flip it upside down and use it, it's extremely cold because of how it expands and creates pressure, which is like an instant set for hot glue. So if you hot glue something and you need it to cool real quick, take that compressed air upside down, spray it, and it will like basically cool it instantly. So those are traditionally oil, actually. All right. So if you can go the way of basically having an aquarium with your computer in an aquarium. All right. They use oil, like baby oil or something along that side, which is non-electrically conductive. All right. Which actually, if you have pure water, it is not conductive. H2O is not conductive. That's why if you spill a cup of water on your computer, you're probably okay. If you spill a soda onto your computer, all the crap that's in that soda, the sugars and everything else, that is what's going to cause bigger problems. Yes, the water could short circuit something, but that's a temporary short. Probably, yeah. I think so. But yeah, so tap water, there's crap in that makes it conductive. So just kind of a fun little side note there. If you do spill something on your computer, doesn't matter what it is, turn it off. And if it is something with sugars and things that's going to get sticky, clean it really well. All right. Take your battery out if it's a laptop. Take a toothbrush. Again, dump some like deionized water or alcohol or whatever, and just kind of scrub it with a toothbrush. Let it dry really good, and then turn it back on. You'll be fine. Most of the time, at least. All right. So up to the motherboard. Now I've got a little bit of a three-dimensional motherboard up here right now, which I find kind of hard for you guys to see what's going on. But I do have a few things pointed out. We've got a CPU right there at the top. We've got our expansion slots on the left. We've got and then drive controllers on the right. On this side of the room, I have a whole bunch of random parts. So if you guys would pass those around so everyone in the room gets to see them. You guys just want to look and then pass them across the room for me. I will move these. I don't want to put that on your computer. But anyway, I don't have processors or anything, but I do have a motherboard here. So on your motherboard is all of the different important parts. Let's go to the 2D view. That one's a little bit better. So we have our CPU socket. Now, unluckily, every manufacturer and many different versions of CPUs have different sockets. All right. So you can't take your 12-year-old computer, buy a new CPU, and just slam a new CPU into it. All right. It doesn't work. What you can do, possibly, is take your 2-year-old computer and put a new CPU in it. It really just depends on the upgrade path and what Intel or AMD has decided. So it's something that you just want to be careful of if you're thinking about future upgradability. And how long. If it's the first generation for that CPU socket, you might be fine for another 5 or 10 years. If it's already been out for 5 or 10 years, the next generation might not have that same socket. Yep, computers are wonderful. Yeah, I used to say, give me an old 4-stroke with a carburetor engine on top, and I would be very happy. Yep. Give it some more fuel, it'll be fine. All right. Anyway, CPU socket. All right. You also are going to have PCI, which are what's down at the bottom. All right. Those are for expansion slots. There are different generations of PCI, so you do want to be careful. All right. If you look really closely at the slots, you'll notice there's PCIe and PCI2. And then you have by 16 or by 4 or by 8. It's this like never-ending game when it comes to PCI. So when you're ever looking at buying an adapter for your computer, just make sure your computer actually has a slot for that. All right. Traditionally, like you want a graphics card to be in a 16x slot, which means there are 16 lanes for communication. The more lanes, the faster you can communicate. There are some tools out there that you could take like a 16 slot and maybe divide it into 2 8x slots. But that is definitely something that, again, you want to be very cautious of. You have RAM slots, which up on the screen are those 4 slots that are very equal in length. There's some debate for me about whether you want 4 slots or 2 slots for RAM. You want at least 2, but that way you can do dual channel configuration. You could have triple channel. At home, I actually do. I have my Xeon processor is a triple channel setup. So I have 12 gigs of RAM, which I'm like, that's a really weird number. 12 gigs doesn't, but it's 4. Yeah, but it's 3 4-gig sticks. So I think I actually have 6 slots in that one. So that would be why. But yeah, so you want at least 2. So that way you can do dual channel, or as I was just saying, triple channel might be a thing, but it's normally more of like a server thing. It's not a traditional PC thing. The 4 slots takes those 2 and just gives you a place to put 2 slots on one channel. Some people say it causes your computer to slow down because of how they have to map things and whatnot. Now, for the average person, are you going to realize that slowdown? No. But having those 4 slots allows you to upgrade cheaper in the future. The other thing that you supposedly want to do is match the chips that are on the RAM. If you actually look at the individual chips on your RAM sticks, those should match for everything in your computer. So you don't want to buy like a Kingston one that has chip A here, and then a Kingston one that has chip B there, and then a different brand here. You really want those chips to be the exact same. Again, how much of a performance input is that going to hurt you? I don't know. I can tell you that I did not follow that rules on my old computer when I built, and I was like, 6 gigs of RAM isn't enough. I'm going to upgrade this because it had 2 2s and 2 1s. So I got rid of the 2 1s, and I think I put 2 4s in or something like that. So I gave myself a nice little boost of RAM speed there. So that's your RAM. That's why you have 4 slots, so you can often upgrade. Laptops, older laptops at least, you used to be able to upgrade the RAM. Some of the newer ones, the RAM is soldered right to the motherboard, so it is what it is. So be kind of careful about that when you're buying a laptop if you're thinking about upgradability for the future. Make sure, I highly suggest for upgradability on your laptops, you can at least upgrade your RAM and your storage. Those are my 2 suggestions. Not always going to be the case, so just something to kind of think about. You're going to have some sort of power connector on here. Basically, every motherboard for a desktop nowadays has a 24-pin connector, and some of them have another 4-8 or maybe dual 8s or something like that for extra power for that CPU. Especially Intel, since they're so power hungry, they're going to have another wire coming over to get more power to that just for the CPU slot alone. SATA connectors are, I don't want to say on the way out. I don't think they're truly on the way out yet, but they are kind of being replaced. So SATA is how hard drives are nowadays being used. Most of the hard drives that I had you guys looking at here are IDE, so they're like 26 pins. All right, SATA, much smaller connector, which is nice. So that SATA kind of replaced the IDE, and I'm not guaranteeing this. I'm not saying a whole lot, but M.2 is the new storage solution. All right, it's this little stick that it's about the size of a piece of RAM. It's actually smaller, and it just slots onto your motherboard and you're done. No cables, no power wires going into your hard drive. Just a little like onto the motherboard and you're good to go. And again, you can get like 1-2 terabyte drives that way. So you can get a lot of storage just right on your motherboard, which is nice. No, some of them are PCI. Oh, yes. Yes, okay. Correct. So M.2 is all SSD. Some of them are SATA speeds. Some of them are PCI. NVMe. That's the PCI one. So a little bit of give and take going on there. Again, for the average person, you're really going to really realize that difference in speed, personal opinion. You're going to have your I.O. board, which is on the back, which I have on the next slide, so I'll come back to that one. And you'll have headers for things like USB to plug into, and your front panel connectors, like the power button on the front of your case. You ever think about how that's there? Well, there's a header on your motherboard that it gets plugged into to get USB on the front, audio on the front, power button, reset button, a little hard drive indicator light, whatever the case is. Why did you just disconnect on me? All right, but anyway, headers. Next, there's 2 other really important things on your motherboard. Your BIOS. This is your basic input-output system. All right, the BIOS, there's a chip that's on the motherboard, and it's normally a read-only memory or ROM. Not normally, it is going to be ROM. Your average person isn't going to edit the ROM on this ever. This is non-volatile, which means when you lose power, it doesn't forget anything. All right, so that way, every time you turn your computer on, it knows what to do. This is going to test and initialize the hardware and to then also begin loading the operating system. So it's like, okay, I need to make sure all the stuff that's on the motherboard are working correctly, get them all booted up, ready to be used, and then go, okay, I'm supposed to now start loading the hard drive, and according to the BIOS that you set, I'm going to go to the hard drive for it, or the CD, or USB, or network, or whatever the case that you set stuff up for. The next, we have CMOS, which is your complementary metal oxide semiconductor. This is where your settings that you can change in BIOS get stored. So if you have BIOS that says, again, like boot from the USB or boot from the hard drive, it's actually storing that on the CMOS chip. Now, the problem with the CMOS chip is it's volatile memory, which means if you lose power, it forgets all your settings. All right. Now, the benefit to that is when you've completely screwed up your computer, you can reset the CMOS by hand by taking the battery out, because there is a little coin cell battery on your motherboard. And that will reset everything, so hopefully you can still boot your computer if you screwed up overclocking or settings or something like that. So that is the benefit for that one. Now, looking at the I.O. So here is an I.O. panel on the back of I don't have it on there. But anyway, this is a newer motherboard. This one's actually, I'm going to call it a gaming motherboard, because up at the top, you notice we've got 2 buttons. We've got a BIOS and a CMOS reset button. So if you have a fancy enough motherboard, you have a button on the back that you can press to actually reset your CMOS, instead of having to open this case, take the battery out, unplug it, let everything die off, and then put the battery back in and restart again. This actually has a button you can press to do that. So that is definitely more of a fancier feature. This also has a BIOS button on the back. Some computers, these are going to be traditionally older, or again, maybe the server quality, are going to have a PS2 connector. Now, I'm not talking the gaming system PS2. All right. I'm talking the old school way of plugging a computer, keyboard, or a mouse in. All right. Some people prefer PS2 keyboards over USB because they are like directly hooked up to the computer. They're not through a USB controller and everything else. So if you have a PS2 port, it's a little like circular one. If you're ever having really bad keyboard and mouse problems, try to find an old PS2 keyboard and plug it in, because that will bypass any USB issues or things like that. So there is a bit of a benefit in that aspect. We also have USB ports up here. All right. Now, you see there are 6 blue ones and 3 red ones. All right. The blue ones are going to be USB 3.0. The red ones are 3.0 at 10 gigabit. If you actually look, it says super speed 10. All right, so the 10 tells you that they are a much faster speed. I actually have some more information on USB on the next slide. We have a optical audio, which is on the far right. It's that funky little like white square neck right with all the audio, like headphone plugs. All right, it says SPDF out up there. That is optical audio that's meant to go to either a like surround sound receiver or to your TV or something like that for better quality audio. We also have 5 audio ports on this one. If you notice, it says rear, line out, line in, mic in, and I don't know what the other one is. See something? But that is for doing multi-channel audio. So you'd have your traditional two front and center, left and right, and then you could add a rear, left and a right, or whatever else the case is. So that's what's going on there. We have an HDMI port. This is back over on the left by the blue USB ports, that bottom left one. Looks kind of like a D sideways, because we've got a kind of squared off, but the corners are cut. You may also see VGA, which is traditionally going to be blue. If you actually look at these computer monitors, there is a VGA port on the left-hand side, right below the USB ports. All right, so that is what VGA is. That is kind of coming of an older standard at this point. Again, we'll talk more about that later. DVI is another one. USB 3 already hit up. Ethernet. We have 2 Ethernet ports on here. All right, one of them is probably going to be a gigabit. All right, the other one might be 2.5, might be 10. I'm not sure. Looking at this picture now, it says Republic of Gaming on the side. That's, I believe it's ASUS, Asus, Republic of Gaming. So that is this mother brand board. So that red one, either going to be 2.5 or 10 gig, if I had to guess. We already hit the audio. Other ports you may see that I don't have. Actually, another one. Wi-Fi. This one has built-in Wi-Fi on it. You see there's those 2 circular connections with Wi-Fi in the middle. You may want Wi-Fi. You may hate Wi-Fi on your desktop. Personally, I'm a big fan of, if you can plug it in with the Ethernet port, plug it in, all right, because you won't have Wi-Fi issues then. So that is my big suggestion for you. Fun quick story about Wi-Fi. There was a company, I don't know who it was, this is obviously a story told to me, and somebody was using their computer, and every day from like 12 to 1, they had intermittent Wi-Fi issues. Every day. And they had IT out constantly, like trying to figure out why there is these Wi-Fi issues. Turns out that his office was on the opposite wall of the microwave. So from 12 to 1, when people are heating their food up, it was putting off radiation, RF radiation. Wasn't supposed to be, but it was. The microwave was. And it was screwing up the Wi-Fi for that computer that was right by. So they put a random Ethernet cable to it, and all was well and good. All right. Or they might have been able to go to the newer Wi-Fi standard, which, again, we'll talk about, I think, on a later slide. So it's just kind of one of those like fun little stories of things you wouldn't normally contemplate, of like, oh, a microwave is going to screw up my internet connection. But microwave is all about radiation, which is all about RF. So it does kind of make sense that a microwave could screw up your Wi-Fi link. So other things you might see FireWire, which is, again, like an older standard. This was probably like USB 1 days. It was like the go-to for transferring like video and data off of cameras and things, which is kind of annoying to me. Up there, we do have a USB Type-C port, which is right there at the bottom of those red USB ports. All right, that little wonderful like ovally connector. I am a huge fan of the world of USB-C. It's kind of standardizing things. You do want to be a little bit careful with USB-C, because it can go anywhere from 0 volts, I believe, up to 5 volts up to 20 volts, and up to like 100 watts, so 20 volts at 5 amps. So you can output a lot of power over USB, which is why a lot of smaller laptops are actually charging with them now. So instead of having a dedicated charging port in brick, it's just plug USB-C in and you're good to go, which I am a big fan of. So USB-C is starting to like kind of standardize a lot of things. So it'll be interesting to see where that goes. You also could have Thunderbolt over USB-C, which is actually PCI lanes being sent over your USB-C connection. Which allows you to do like an all-in-one dock. So You walk your laptop up, you plug it down at your desk with the USB-C connection. It charges your laptop. It does an external GPU. It does a whole bunch of USB ports and networking and things. And it connects you to an external monitor, keyboard, mouse, whatever the case is. So it's a one cable dock. All right, and it's a non-proprietary dock. There used to be like ports on the bottom of laptops that you could then set down, and that would like connect everything. Or on the older, no, not this one. Some of the Lenovo's, there's like a wide port with a USB-C port or something built into it. But anyway, it's USB-C is becoming a very powerful tool. Is what it comes down to. Here we've got the different USBs. So we've got USB 2.0, and then we've got USB Super Speed, which is 5. And you can see that's Gen 3.2, 1x1, 3.1, Gen 1, 3. Anyway, there's a whole bunch of different options here. And it's really, to me, quite annoying. All right. USB 4 just came out, if I remember correctly, like very recently. All right. And this doesn't also show you about Thunderbolt, if Thunderbolt is part of that USB-C spec or not. So it sucks, is what it comes down to. They need to get some better standardization and some better freaking naming than USB Super Speed 10, 20, and 40. Why don't we call it just USB 3, 1, 2, and 3, 1, 2, and 4, something like that? Like, can't do it. Your RAM in your computer. All right, up there I've got a nice little variety of different generations of things. RAM is volatile, which again means if you lose power, it forgets what's on it. So RAM is meant for a temporary storage. We've already talked about how you can have multiple chips or multiple boards. And there you can see all the individual chips, and it said those are what should be consistent from one stick to the next in your computer, supposedly. I've never, again, tested that fact. Well, you're going to have what's called a DIMM, which is a dual inline memory module. All right, that's what you see up there. Those are those 4 big sticks on the right. The little stick on the left, that is your SODIMM. This is a small outline dual inline memory module. So if it's small, you probably guessed it already, it's meant for laptops. All right. So they just kind of shrunk the RAM sticks down as much as they could to make them fit better in laptops is what it comes down to. And then we also going to hear the term DDR, which stands for double data rate. So we are up to generation 5. DDR5 is available to buy. It is still in its infancy, which means the RAM is still stupid expensive. All right. Also, unless you're buying a brand new motherboard, you're not going to buy DDR5 because RAM is not backwards compatible or forwards compatible. My next slide will make that a little bit more obvious there. You do want to make sure you're buying RAM for your specific motherboard. So if you're going to upgrade it, you're like, I got an old desktop. If you have an old desktop sitting around, throwing an SSD and more RAM at it, like if it's like 2 or 4 gigs of RAM, and you can upgrade it to 8 or 16 gigs of RAM, and it has a traditional hard drive, one of the big ones that spins, to an SSD, that's going to feel like a brand new computer. My last job 6 years ago, they determined that they were going to skip buying new computers for one generation. And they were just going to upgrade the RAM and SSDs and everything. So it saved them thousands of dollars per computer. It's like, okay, we're going to buy a new computer for $800,000, or we can buy a new RAM and hard drive for like $100,000. So that's what they did. They upgraded every computer that way, and they got another 3 years of life out of those computers. So upgrading those 2 things can make your computer feel like brand new. So I highly suggest that one if you got an old computer lying around. So DDR. Upgradability, yeah. All right, last thing is cache memory. Now, cache memory is not something that you can replace. This is built into the CPU, and there are different levels of cache. I believe it's like 1, 2, 3, and then RAM or something like that. And as you go closer to the CPU, the memory gets faster. But it also shrinks in capacity. All right? It would be wonderful to have level 1 cache, like 50 gigs of it, but it's not plausible. All right? So as you go up that tower for cache, it's the amount's going to shrink, but the speeds you have to access it will increase. So, yeah. Okay. So here we have the DDR slot comparison. I must only have 1 through 4 here, but you can see the little notch taken out of the bottom. Yeah, it's 1 through 4. Is in a different place on each one. Some of them are really freaking close. 1 and 2 are only off by, I don't know what my scale on the right there is. I'm guessing centimeters. 3 and 4, there's a big difference in the slot, but like 2 to 4, it's minuscule. All right. So it is kind of annoying that they've got them that close. Now, the likelihood of you trying to put a DDR2 in your DDR4 slot is pretty slim because DDR2 was kind of extremely outdated by the time 4 came out, but still something that you just want to be worried about. So the nice thing with having those notches in different places, it will physically keep you from installing the wrong RAM in your computer. So You're not going to blow something up that way unless like you cut the little plastic away that keeps you from putting the thing in, which I'd be very impressed about if you were able to do that. So how much RAM do you actually need? Yes.
One question about cache. Rising caching works. I know it does something.
Not a clue. The only thing about 3D caches, I think they're like stacking it on top of each other, which is why it's 3D. It's not just like one layer, it's multiple layers tall. But I've got no clue beyond that. So, how much RAM do you need? All right, and this is where I say, if I'm buying a computer nowadays, nothing will have less than 8 gigs of RAM in it. That if I went to Best Buy right now and there was a computer that had every spec perfect but only had 4 gigs of RAM, I'd either walk away from it or I would buy it assuming I'm putting new RAM into it right away, like first thing. All right, because Windows 10 wants 2 gigs of RAM. So if all you're going to do is run Windows on your computer, not open a single application, you need 2 gigs of RAM. Oh, but you'd obviously want to open apps, right? It's the whole point of having a computer is to open software and applications. So you're like, okay, I'm going to use Word. You need another 2 gigs. Oh, you also want to have the web browser running? That's another gig. All right. And Chrome is probably even worse than Edge. Chrome is a resource hog. I'm just now curious what that means about my lovely recording that I was doing. Yep, I'm down to 5%. Great. That really burned through battery today. Oh, and are we recording? All right, so anyway, Chrome, I said, going to be a bit of more of a resource hog. So then we have iTunes, which is 2, and Photoshop, which is 4. So if you want to have all of that stuff running at the exact same time, you need a minimum of 11 gigs. All right. Now, how do you know this? You can go look up minimum specs for things and those types of stuff. But this is also why I'm like, yeah, I'm just going to put 16 gigs in most computers nowadays if I'm buying something. Now, my computers I have, I may not be upgrading. Just kind of like let them go. See what happens. My desktop has 16 gigs. This laptop HTC gave me has 16 gigs, which is nice. I have a home laptop that might have 4 or 8. I don't remember. Probably has 4, but all we do is web browse on it, so it's not like it's really doing anything major. So not really too much of a worry there in that case. Which leads us to some input and output devices. All right. This is where the book really starts to change from the previous one. Keyboards. All right. So your traditional keyboard is QWERTY, which is QWERT. It's the top row of actual letters. That's where we got QWERTY from. Which actually, I like this picture. It tells you that like 52% of the keys that you're going to touch are on that top row. 32's in the middle, 16's on the bottom. And I didn't know this, but the reason that we have this keyboard layout is for typewriters. So when you have those old mechanical arms that would move, if you would press 2 keys right next to each other too close in succession, it would jam. So the reason they have QWERTY is to try to spread the letters out on your keyboard that you use frequently, so that way the typewriter is less likely to jam. Which, thinking about that, I'm like, that makes a lot of sense. All right. However, we have the Dvorak, I don't know if I'm saying that right, keyboard, which places the most commonly used letters where they are most easily accessible. So the top one is Dvorak. You can see 70% of the keys you're going to press are going to be on that middle row. So just resting your fingers there, it's AOEUIDHTNS. All right, I'm a little surprised that R is not there. RT. Oh yeah. Anyway, so Dvorak, it just changes the location around. Now, you do get to pick the layout of your keyboard on your, I think on Windows. On Linux, you definitely can say like, this is the keyboard I'm using. And you can tell it like a specific, like, so that way when you press the A, it's not necessarily actually A. You could tell that you're using a Dvorak type keyboard, even though your keyboard's normal, and it would remap all the buttons for you, which would really screw someone up who's trying to type on your computer and not realizing that it's a Dvorak style. And then they would have to memorize where all the buttons are. All right. Hopefully, you all are good enough typers that you don't actually have to look at the letters when you're typing. My father is not. He still uses the wonderful two-finger approach and does one of these skills. The hunt and peck, as I believe it's called. So it would be annoying for him to go to this, but not the end of the world. In fact, when he's texting somebody, which he tries to avoid, he just hits the microphone button and says it instead of actually typing it all out. So just kind of a fun little side note there. But anyway, that is the QWERTY versus the Dvorak. All right. Next, we have ergonomic keyboards. All right, which are there to supposedly help you reduce. You put your hands in a more natural position. Right. Your hands are, if you just kind of curl your fingers, they're not flat. The fingers, are curved. All right. So the Dvorak, or not the Dvorak, the ergonomic keyboards are there to put your hands in a more natural position to help reduce strain. So if all you do all day is type, I'd highly suggest you look into a better ergonomic keyboard for yourself. It will help keep your fingers happier longer. All right. So definitely something you want to do. Up on the screen, I've got two different ones. On the bottom, we just have like a normal curved keyboard, which to me looks really freaking weird. This is one of those things that I would love to test, but I don't want to spend like $100 whatever on a keyboard and find out I hate it. Or buy it and then find out I love it and then we'll have to put one like everywhere I use it. All right. Anyway, so the bottom is ergonomic. The top one is what's called a split keyboard, so you can actually put the boards, within reason, farther apart, again, for your ergonomic benefit. That way your hands, you're not pulling your hands in and bending elbows. You can kind of have your hands spread apart some. So you can get split keyboards like that. There is a whole community on custom keyboards. To the point of which button do you like? Do you like the clicky one? Do you like the soft one? Do you like the one with the hard bump stop at the bottom? What type of key do you want? And there are probably thousands of different actual key buttons. What you guys are all used to using is stupid membrane keyboards. That's what I use. I'm perfectly used to it. It's fine. But it's basically like a little piece of rubber that when you push down the key, it pushes on the piece of rubber, which then creates a contact between the PCB and a conductive surface. All right, where a mechanical keyboard, which is where most people who are building custom keyboards are going, are actual switches that when you push them, they actually put contacts together, and then when you pick them up, they unclick, and all sorts of wonderful things. So there's a whole world of people building custom keyboards for our heart's consent. That takes us to keypads. All right, how many of you guys like having a keypad? I do. I love having a keypad. All right. Some of you are like, nope, I don't need one. I can use the number keys on top of the keyboard. Some laptops build keypads into the touchpad, so you hit a button and it goes into keypad mode. I would not touch that with a 10-foot pole. I mean, I'd try it once, but I'm most likely gonna be nope, not using that. All right. So you can have a keypad, just the number pad on the side, no alpha keys. We do have what's called modifier keys and toggle keys. So Control, Shift, Alt, and Function, those would be modifier keys because they are temporary. So you have to hold them down while you're pressing something else. Unless you put your computer into sticky mode, which basically you press Shift once and it's like you holding it until you press it again. This is one of those adaptive things. All right. In fact, if I just touch tab control, no, if I tap and hold control too long, maybe. I don't remember. One of those, it's like tapping a whole bunch of times in a row or holding it for too long. And Windows is like, hey, do you want to put sticky keys on? And I'm like, no, don't tell me that. All right. But anyway, so that's what sticky keys is. Then you also have the toggle keys, which are permanent until you press the button again. So that'd be your caps lock and your number lock. All right. You also have a scroll lock as well, but I don't know anybody who actually uses that button on their keyboard. If you have a full-size keyboard, laptop keyboards doesn't have scroll lock that I've ever seen. So you can have, like I said, a function button. So function is traditionally a laptop thing. I have a function button on my keyboard at home that takes my F row and just like function here, except for you don't have to hold it. It's like standard mode or function mode, and you just tap it once and it just converts it for you. So little give and take. And as I was mentioning earlier with my computer, I have to hold the function key down to use normal F keys. That's traditionally a BIOS setting. So if you use the F5 for refreshing your screen all the time, and you don't change brightness or volume or things, maybe you want to disable the function lock that's already built in. So that will be in the BIOS setting there. After keyboards, we have pointing devices. All right. So you all are used to the standard, I'm going to call it 3-button mouse. All right. That's what you have in front of you. Many of you don't know that the scroll wheel is traditionally also a button. That is the middle click. That does something. What? I don't know, but it does do something on most computers. All right. So we have our traditional mouse. Said buttons and a scroll wheel. Scroll wheel is technically optional, but I don't know any mouse that doesn't have a scroll wheel on it anymore. All right. Most mice nowadays are optical. So there's a little red laser or LED shining out the bottom, and there's a optical sensor, basically like a very low resolution camera there, and it's actually tracking what's the picture that you're taking. All right. This is why optical mice don't work on all surfaces. If you ever in one of my classes in the STEM building and you try to use a mouse on the black like science tables, they're so reflective that the mice can't track it. So you have to put it like a book or a piece of paper if you want to use a mouse in that classroom, which is kind of annoying. But that's why there's mouse pads, so that you do have something that's not super reflective and trackable. Old mice actually had a ball underneath it and little encoder wheels. So if you ever had one, actually, I have one up here. This is one of the fancier ones. And there are actually little encoder wheels inside that ball spins. But the ball tracks lint, which gets stuck to the encoder wheel, so they would stop working. So you would actually take the ball out and go in there and have to like clean the little wheels off every once in a while because there'd be so much lint built up, the ball wouldn't actually spin the wheel, which got very annoying. So optical mice were a big win at that point. After our mouse, we have a touchpad, which is what's kind of centered on the screen up there. You all should be used to those on laptops. I used the word touchpad someone yesterday, and they're like, "What's a touchpad?" Like, the thing on a laptop? They're like, "Oh, okay." I had no clue otherwise. Some laptops, like my laptop up here, mainly Lenovo does this, has the little pointing stick, the little red nub right in the middle of the keyboard. I don't know anyone who actually likes those things. I'm sure there are people who are diehard fans. The big benefit is you don't have to take your finger off your keyboard if you use your thumb on that pointing stick. It's just right there under your keys, so you don't move your hands to go from trackpad to keyboard back and forth. We have the track ball, which is down here at the bottom. This is traditionally more of an accessibility mouse, so it's someone who can't move the mouse around, but they can spin a ball. It's like taking a traditional ball mouse and just exposing the ball so you can push it with your finger. All right. This is another one of those mice that I'm like, if I really had the time and money, I'd like to try one out for a week and see how long it takes to get used to doing, and is it more, is it better for me and whatnot. So a little bit of give and take going on there. You have touchscreens, which are what you obviously have on your cell phone. Some laptops have them, tablets. You can get a computer screen with a touchscreen built into it, or you can actually buy an overlay for your computer screen. They don't make all shapes and sizes, so you have to be kind of careful there, but you can add touchscreens to some computers. There are two types. There's the older technology, which is resistive. All right. This type, it's actually measuring the pressure on the screen. The problem is resistive, you touch down with your whole finger. It's not a precise point. So it's guessing where the highest pressure is and averaging it and saying, oh, you clicked here. And that might be to the right or left or up or down of where you actually wanted to click. So that's a problem. So when resistive screens, I highly suggest either using your fingernail to get a very precise point, or like a lead pencil that doesn't have the lead exposed. It's like a plastic thing. It's a nice way to touch it. Next, we have on the touch screens, we have capacitive. This is what current technology uses. The benefit of capacitive is we have multi-touch. So most devices, like cell phones, you get 2, 3 fingers, maybe 4. Some laptops, you have like 10-finger multi-touch going on, so you can actually detect 10 different touches at the exact same time. When that's useful, I've got no clue. I understand like 2 or 3, having like a kid's game where both are like playing Pong and just touching and moving the screen, moving their paddles. Obviously, we pinch to zoom and things like that, so that's where 2 fingers comes in really well too. Fun side note there: a French fry will work on your capacitive touchscreen. All right. Another fun note: I was out cutting wood, so I have a wood fireplace at home, and I have my gloves on so I don't get my hands beat up, which obviously means I can't use my phone because my gloves aren't touch compatible. They don't have the special touch finger points. But my glove was leather, so I licked my leather part, and then I could use that part to touch my screen, and it worked. So it was a way to get around not being able to interact with my screen without taking my glove off. Was it the best method? I am sure licking my glove is not my best method, but it worked. That was what was important to me. So kind of something to think about. And the last one are interactive whiteboards. I wish we had one here so I could demo it to you. We just have a boring old projector with a screen. All right. But the interactive whiteboards traditionally are using some sort of pen. They're not traditionally touch. There are some that are touch, but most of them, they have a digital pen that there's a